So in this particular thing, we're looking at where we're going to get these formulas from to use later on. As I've set up the top, you don't need this in your notes. You will need the diagram that we need at the end of it, but it's always nice to know how come we're doing what we're doing. So what we're going to have this time is we're going to have a specific force, or it could be a distance, or it could be anything, but 95% of the time you're going to be working with force. So we've got a certain force going in this direction, and we want to know what part of that was horizontal and what part of that was vertical. And there's going to be uses for this later. For now, it's just building up the skills of what it is. So I'm going to start with the horizontal part, and for now I just could call it A because it's adjacent to that angle. We're going to call it something different later on, but we know from trigonometry that cos theta is opposite over adjacent. So cos theta is adjacent over hypotenuse, So A is, we've still got A, and the hypotenuse in this case was x. To get that x off the bottom, we multiply both sides by x, and you end up with x cos theta is equal to A. So we know this side is x cos theta. Now we don't write it that way as A, we call it the horizontal component of the force. So F with a little subscript of a h is equal to x cos theta. Again, these will be on the next slide to write down. Don't worry about writing them down from this point. This side here we'll call opposite the angle for now, and we have sine theta is opposite over hypotenuse. Sine theta is opposite, and in this case the hypotenuse was x. Multiply both sides by x. X sine theta is O. Now again, we don't call it the opposite, we call it the vertical component of the force. So it's force with a little subscript v is x sine theta. Now, it will be on the next slide to write that down properly. Don't worry about copying that down there, it will be neater and better set out on the next slide.